So here we go. We're still working on 1.2. Yesterday we started and we did one that had a radical, an x underneath a radical, but it ended up being a quadratic. Okay. So I'm going to give you another one like that, and I want to see if you can do it. So after that is equal to. Now look, here's what we're practicing on. We're looking at domain. When I say domain, you think restriction. Very good. What are the two restrictions? An x under the radical and an x in the denominator. Very good. Okay, so I want you to do this problem. And I want you to tell me what the domain is. I want you to write it in set and interval notation. Okay? It is. It certainly is. Because remember what it says to do if you have an x under the radical? It says take what's under the radical. Don't care about anything outside the radical. Okay? That's not messing with my domain. That might be messing with my function, but not with the domain of the function. Any parentheses up there? Okay. Here's what I'm going to say, okay? If you're kind of stuck somewhere, then first of all, what do you know that you have to do? Take what's under the radical, set it greater than or equal to 0. And then you have to factor it, right? Y'all listen to me. Am I going to factor it with a negative right there? No. I'm not. I told you not to do that. I think you can if you want to, but it probably makes it hard. I'm going to take that negative out, and I'm going to factor this. Now, all that negative does is tell me what? No, what's that negative do? It tells me one thing. That my parabola opens down. That's all it tells me. Okay? It doesn't have anything to do with my root or anything. You'll get the same answer. Your root. You're like halfway through. Back. All right, y'all got it? Okay, so I'm going to factor this. Factors into x times x. What's the plus sign at the end mean?
Plus one, the same
That's the
sign.
same, and the same as the first one. So minus and minus. What are the factors of 6 that add to be 5? 2 and 3. Okay? So if x minus 2 is a factor, what's the root? If x minus 3 is a factor, what's the root? Okay. So now we're going to graph it and just find our answer, okay? Now, is the graph our answer? No, y'all, the graph is just a way to cheat to get your answer, okay? I don't have to. All it does is tell me that it opens down. Okay, so this is 2 and this is 3, and y'all said my parabola opens down. Okay? And then I go back up here and I read the problem. It says, hey guys, I want the part of the parabola that's greater than 0. Is that above the line or below the line? Greater than 0. What is it? Above. So what do you want? The hump or the tail? The hump. Okay, so if I want the hump, where are the x's that give me the hump? Inside. So these are all my solutions. And here, this is my domain. Does it include the 2 and the 3? Why?
Because they're on the line
Because it's over equal to right there.
How do you know if it's outside of
The tails are outside and the hump is inside. Okay? So what is my domain? Look, this is an x between, so I'm going to put it between the two numbers. I'm always going to point my arrows to the left. Remember that your arrows always have to be pointing in the same direction. If you point your arrows to the left, the smallest number goes on the left and the largest number on the right. Okay? That seems very logical to me. That's the way I'm going to always do it. So in stat notation, it's going to be any x such that x is greater than 2 or equal to, pardon me, and less than or equal to 3. These should have the word equal to because we make follow. Okay? In integral notation, oh no worries, this is so easy in integral notation. What's it going to be? 2 inclusive, 3 inclusive. Nope. These are, because remember what the rule said. It said take what's under the radical. Did it say multiply by anything outside the radical? Add or subtract anything outside? No, it just said take what's under the radical and set it greater than or equal to 0. Okay? Alright, everybody got it? Okay, so now I want to do one more problem and then I'm going to quit. This is example 8. Remember also what I told you that, no, it's really short. It's a calculator problem too. Remember when I told you that we skipped some parts in this section? Okay, so if you look back in the book, you'll see piecewise functions. I pulled that out, and I put it with difference quotient, which is extremely important. We use it a lot in calculus, so I pulled that out too, and then I pulled something else out too, but I don't remember what it was. All right, so I pulled that together and I made my own little unit with it. Okay, and the reason is because PreAP, we worked a lot on piecewise functions, but regular algebra doesn't work a lot on piecewise functions. So they may not be as familiar with it. Part of the reason you guys are here. So piecewise functions, where it has this function where x is less than 0, and then this function between 0 and 2, and this function where x is greater than 2. Remember that? It's broken up into pieces. We'll do it. It's not bad. All right, so here's our problem. It says a baseball is hit, and it follows this path. So let's talk about it for a second. Oh, it's easy. Okay? Where x and y are measured in feet. It's hit 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees. So it's hit and it's going to make a what? A parabola. And obviously, it's a parabola that opens down, okay? And here's what's going to happen. The x is going to be how far out it is. okay? Its length, and the y is going to be its height. Okay? Now, a lot of times, have you ever seen a problem like this? Remember that? We've looked at this a lot. This is my beginning height. This is my initial velocity. Okay? And this is my ending height. Okay? No, and normally if they give you, they'll give you this formula right here. What's the difference between this formula and the one we're talking about? What is this one? What's the x on this one? Yeah, it's time versus height. Okay? This one is how far out versus height. Okay? So you're like comparing two different things. Okay? Because my brain almost always goes to this one. So when they give me one like this, I go, whoa, wait a minute. Alright, so but that's what it is. How far out is the x and how high up is my y. So I'm going to put that in my calculator. And then we're going to talk about it. Because I'm going to tell you what the question is. So, negative 0.0032 x r. Plus x plus 3. Okay. Now, I'm just going to graph it, zoom, fix it. All right? Now, here, look what I see. Do I care anything about anything to the left of the y-axis? No, it's a real-life problem. All I care about is really what's in the first quadrant, right? Now, do I need to increase? What do I need to increase? Both the x and the y. Okay, let's get a pretty picture. So let's go to the windows. My x-min, let's see, what do you think? Now, x-max, that's going to be how far out that ball goes. How far do you think that baseball might go? 300? Okay. So, and if we go out to 300, what do you think we might go by? Like 10? 10? That's a lot. How about 20, 25? Let's go by 25. Okay? So, here's what's going to happen. I'm going to do my x-min. I'm not going to start. I could start at 0. Don't need to start at 0. Don't have to. Okay? And I'm going to go out to 300, and then we're going to go by 25. All right. Now, what do you think as high as it's going to go? 90? If you say 90, let's say what? 100. What do we want to go by? 10. Okay, let's see. Oh, y'all are awesome. Look at that. Not far enough? Oh, it's sure not. So, he's a whammer, jammer, slammer guy, right? So, let's say 360. Okay, now, here's the question that they ask us, okay? Will the baseball clear a 10-foot fence located 300 feet from home plate? Yes. Okay? Now, could I put a fence on my graph?
Sure, yeah.
Well,
X equals 10.
X equals 10? Y equals 10. Okay, so I could go to Y equals, and I could go down here, and I could say Y equals 10. There's my fence, right? Now, what do I want to find, guys? Yeah, what if you found out where they intersect? What do we want the x coordinate to be? That's right. See? Yeah. So let's see what it is. Let's go second and calculate. Number 5 is an intersect. All he's going to do is say, hey, lady, is this your first curve? He gives me the equation up there, and he's jumping up and down on it. I say, yeah. And then he jumps down here to this one, and he says, hey, is this the second curve? Just in case you have more than just 2 curves in your calculator. Okay? And he gives me the equation, and I say, yes, and I don't want to play, so I just press enter, and there it is. Okay? At 305 feet, he has gone down to 10 feet high. make it over the fence? Yes, he did. What would be another way you could do it? Oh, what's your question? Oh, you could like make a guess. I don't know, I never did. I'm not a game
Get
player.
close to it, like if there's a bunch of lines, you close, like if you have
We'll try,
intersections
we'll
in
do
different
it.
spots,
Okay?
if you have different intersections in different spots, like can they intersect over here, and over
Well,
here?
then you would move it
Yeah,
closer
close
to that one.
intersection you want.
Let's
Okay,
see.
what's another question?
Okay, let's see. I don't know, we'll just do it. Y'all are such a redneck. Y'all, you know what my husband said the other day when, we found that button on the couch, on my keychain? No, but watch. Watch. He wants me to guess and see if I can guess that one. What if I guess 300? He just tells it to me.
I don't think that's what I'm asking now.
Yes, it is. Watch. I'll
Go back and do that again?
Okay. Alright. Second, number 5. First card. He went over there. Go back, get away from that spot, please. Okay. Now see, if I put him close to this spot, he'll find this intersection
Yeah, that's
over
what I'm
here.
saying. I think that's what it's saying, yeah. I think it's saying,
No, I don't
bring
think
it
it is.
closer to that one.
I don't think so. I think he wants you to make a guess. Okay?
Why would you guess though?
Some people like to play. Some people like to play games.
Speculate on it.
Maybe
Like,
no. Let's say, I say 320. He's going to jump on it and say, you're not right, girl. See? He said, no, you're not. I know.
No, I think it's like, get like, you know, what's the exact stuff? Yeah. What try to do, what can you say?
Well, it will. If you move it closer to this one, you'll find this one. That's my guessing.
I think you need that guess with yeah, if you go to guess, the calculator don't play it. Like, which one do you want him to get? Like, that one or that one? There might be like 4 different intersections.
I don't think so. I'll let you try. Okay, so there's one way. What about this? What if I went to second and calculate and I chose a value? How can I find my answer out here? Oh, Jessica said, what if you put in 300? What am I looking for it to be? Over 10 feet. That's another way you could do it. Is he going to make it over the fence? Yeah, here, we simply we have second and calculate a value, number 1. Yeah, that's what he does. When you do this, that's what he does. Okay? Alright, so just all around. Because he wants to play games and play Bible. Alright? So, anybody got a question?
I think the girls are just reading them wrong. They can't wants to play games.